Okay, in this video, we're going to go through the notes on the work that I'm asking you to do. So at the top of the page here, it says calculate the percentage of nitrogen in ammonia and ammonium nitrate. So to do this, we have to remember that ammonia has the formula NH3. And what we're going to try and find out is how much of that formula is nitrogen. So the first step to do is to calculate the relative formula mass for ammonia. And to do that, I'm gonna come to this side a little bit over here. To do that, we separate this out. So there is one nitrogen. So nitrogen has a mass of 14 from the periodic table. There are 3 hydrogens, each with a mass of 1. So that gives me 3 in total. Add it up, and I get a total relative formula mass for ammonia of 17. So if I want to find out the percentage of nitrogen, what I need to do is put the mass of nitrogen, how much nitrogen is in this formula. So I can see from here there is 1 nitrogen, and we've just said that nitrogen has a mass of 14. So I'm going to put that at the top. And I divide it by the total mass of the whole formula, which we've worked out to be 17, multiply it by 100 to get a percentage, and that gives me an answer of 82%. So 82% of ammonia is nitrogen. Do the same on this side for ammonium nitrate. Let me give you the formula. So ammonium ion is NH4. It'd be a positive ion. Nitrate is NO3, single negative. So the formula overall of ammonium nitrate is NO4, NO3. Okay. To do the percentage of nitrogen again, what we need to do here is work out the relative formula mass for this ammonium nitrate. So I'm going to do that over here. There are 2 nitrogens in here, so each nitrogen is a mass of 14. 2 of them takes me to 28 for nitrogen. There are 4 hydrogens, mass of 1 each is 4. There is 3 oxygens, so that's 16 each. So that's 16, 32, 48. You add all that up, and that should give you an answer, hopefully, of 80. Then what we do is we use our same equation. So the percentage of nitrogen is going to equal the mass of nitrogen in the formula. Now remember, you've got 2 lots of nitrogen. So the total mass of nitrogen in that formula is going to be 2 times 14 is 28, divided by 80, and then multiplied by 100. And that's going to give you a percentage of nitrogen in ammonium nitrate of 35%. That's just to practice some of the calculations we're doing based on the chemicals that are used in the Haber process, but also to make fertilizers. This next little bit is looking at how we produce and prepare a sample of ammonium sulphate in a laboratory. So let me take you through this. To do this, ammonium sulphate is a salt. So if we can carry out a neutralization reaction, then we will produce the salt, ammonium sulphate. And to do this, we need to take the 2 chemicals that are going to allow this salt to form. So the ammonium is going to come from ammonia. So I'm going to react ammonia, and I'm going to react it with, in order to get a sulphate, I'm going to react it with sulfuric acid, so that it will be neutralized. And that will make, as we've just said, ammonium sulphate. Ammonia is NH3. Sulfuric acid, remember, is H2SO4. Ammonium sulphate, let's have a look at this one. Let's use our technique to work out the formula. So the ammonium ion is NH4+. And because it's a single plus, it wants to form 1 bond. The sulfate ion is SO4 2-, a double negative ion, therefore it wants to make 2 bonds. Cross these over. So the formula is NH4. Now the NH4 is going to get the 2. The 2 is going to come across this way. So in order to represent that, I need to put that in brackets, put the 2 here, and then the sulfate, SO4, is going to get the number 1 goes across to it, so I just leave it as SO4. So the overall formula here for ammonium sulphate is NH4 2SO4. Okay, that equation needs balancing. If you want to pause the video and have a go at balancing it yourself, I'm going to just balance it very quickly by putting that in there to balance the equation. So if you're going to prepare this in a laboratory, we take, as you can see from the equation, we take ammonia, react with sulfuric acid, and it will make the salt ammonium sulphate. This salt is soluble, so we would have to then separate that soluble salt from anything that it may be dissolved in during the reaction. Let's have a look at what goes on. What I've done here is I have for you taken a screenshot of a set of instructions in the steps that you need to take in order to neutralize the ammonia and the sulfuric acid in order to make the ammonium sulphate. A couple of key points in here. So you can see we are using sulfuric acid as one of the reactants, and we're going to react it with ammonia solution. So there's our neutralization reaction. How do we know when to stop this reaction? Well, we stop this reaction when it's been neutralized, and it's been neutralized once the pH has reached 7. So the method that's being suggested here is, in order to identify when this has reached 7, they're using indicator paper, or you can have a pH probe, and that would tell you when it's been completely neutralized. Once it's been neutralized and the ammonium sulfate is present, then what we have to do, because that salt is soluble, is we have to then go through an evaporation process to allow us to get the salt from there. Notice we take care towards the end that we don't boil this, because we don't want anything to be spitting out as the crystals spit out as they form. We allow the solution, once it's started to concentrate, so as we start to drive off the unreacted liquids in there, we allow it to concentrate, and then the crystals will start to form. And then we can separate the crystals by filtering the crystals using filter paper, as you can see there, allowing them to dry, and then we get our ammonium sulfate crystals being produced. So there's the steps that we'd carry out in a laboratory.